Okay, so this is the sorry. Okay, so this is the 16th part of our following tutorial series, data structures and algorithm, and we've been talking about stack implementations and the operations that we can perform by using stacks. So in the previous episode, I've been teach you guys how do you implement the push operation by using stack. So today uh, I'm going to uh, show you guys how to implement the pop operation to the stack. Okay, so basically pop operation means deleting an element from the topmost location at the stack in a stack. So as you guys already know, a stack is only can perform the deletion operation or the pop operation only at the topmost location, which means you can't delete or insert any element at the middle of the places of the stack. If you want to do perform push or pop both operations, you can only do that thing at the topmost location only. So basically uh, so as you can see, uh, in our default state, topmost location is equal to 3 because we have 4 elements in our stack. Therefore, the top index will be 3. So if we perform a pop operation once, this 6 or this element will be popped out, which means now our stack should be considered only these 3 values because we uh, have been just pop out one element. Therefore, the top will be decreased. Okay, so this is not 3, this will be 2. Alright, because we after the deletion operation, the top will be decreased by 1. So basically, you can perform this delete operation until it reaches to the this place, which means the 0th index or the first element. After reaching this position, you are unable to perform pop operation again and again because you have no elements in your stack. Therefore, your stack will be empty. Okay, so what I have been discussed or described this situation, this scenario, or this pseudocode. So as you can see in our pseudocode, we will first check our top is equal to -1 because we want to initialize that our stack is not empty. Because our stack is empty, therefore we can't perform any deletion operation. So if our stack is empty and we perform the operation, it will be saying stack underflow. Okay, because the stack is not having any kind of element, therefore it can't be perform any pop operation. Therefore it should be saying we can't perform this operation because of it is underflowing of the elements of the stack. Therefore it will be saying stack underflow and it will break the process of the sequence, which means it will go to the second state. So if you else statement, which means if our top is not equal to -1, therefore we can perform deletion operation. Therefore it will first get the value from the topmost location of the stack and store it in the value variable. Therefore in later we can perform simply return the value from this function. So you will be saying what I am saying right now in later. And after we perform division operation, the top will be decreased by 1. Therefore, we simply write top is equal to top -1. So basically, this is the pop operation, and how you implement that procedure by using pseudocode. So let's see how we write C code for this operation. Okay, let's move to the code. Okay, so first we should define our header like this. Then we can go our main method like this. And before we go in our main method, we should define some stack. So how we do that? Okay, so first I will define max like this, and I need top, and I need another variable for I, and our stack which having max elements. So in the default state, we are now performing pop operation. Therefore, in the default state, our stack should be having some kind of elements. So I will give these values for that, like this. Therefore, we having 6 element, so the top will be equal to 5. And in the initial state, I will be remained as 0. It is not necessary to define over here. We can define it later. So I think these variables will be enough. Okay. Then I should get input from the user in order to perform the deletion operation. So let's say if user enter 1 by his keyboard, the pop operation will happen, and if user enter -1, this procedure will be end and printed, and they will be printing the remaining elements of this stack. Okay, so how do we perform that? Okay, first I define another variable for that. Let's say num or something like that. Then I'll perform simple while operation over here. I'm checking it is not equal to -1. So therefore in the initial state I will define this num variable as 1. So first they will be printing a message like this. Do you want to perform the pop operation? So the instructions will be, if you want to delete, then insert 1. If it is not, then insert -1, like this, and it will get the input as the decimal point, and it will be addressed, or it will be reference to that value to the num variable. Actually it is not referencing, it dereferencing. So you will be having a proper knowledge about these referencing and dereferencing techniques in later when we are discussing about pointers. So for now, just don't worry about it. Okay, and if we perform, and if we entered num as 1, therefore the value will be deleted, so it will be printing a message called the value is deleted, or popped out, or something like that. So the value will be stack top, right? And if it is deleted, okay, so in here now we should define our pop operation. So I'll make it as another function. It's in pop. So no parameters will be required because it's just simply popping out. So first there will be some procedure like this. So it first checking whether our top is equal to -1. If it is equal to -1, there will be printing a message called stack underflow. If it is not, then there will be a returning our topmost location, topmost value at our top location, and there will be decrementing our top. So you guys now might be wondering why I put minus over here instead of using like this. So I'll show you what I am saying, like this. Okay, so the thing is, after you returning some kind of value from the function, the other things, let's say other steps will not be executed, which means when you are calling this function, this will be running sequentially. The first step will be checked like this, then it will go to this, then it will go to else statement, then it will go to the return statement. So you are directly saying return something, which means this function is defined to return something because it is the final output. Therefore, it will be not execute other things when it take place after this returning method. So therefore, if you write our decrementing procedure like this will be not happen. So that's why I'll simply perform postfix decrementing over here like this. So this is in a single line there will be two operations happen at a one time. Actually it is not happening at a one time. First it return this value and then it considered as the postfixing procedure in order to decrement our topmost location or the top value. So when it comes to coding, you must aware of these things also, because it's not pseudocode. You can't just simply implement your pseudocode in any kind of a programming language, because it is having their own syntaxes. So you should be following these things. So that's why I'm emphasizing this issue over here, because if you never done this stack operation ever before, you might be wondering why my code is not working. So if you are not a beginner, if you are intermediate at this code, this is just a very simple thing, and you might be consider this as a joke or something, because it's that much simple thing. So I'm explaining this to the beginners only. So if you are intermediate or you are do know so much things about coding, you should not worry about these things also. Anyway, this is how you perform postfixing procedure. Okay, so now in here I can call my pop operation. Okay, like this maybe. Okay, I can simply perform it like this. So it will be calling this function over here and it will be deleted and it will print out the returning value over here. And num is equal to -1, therefore it should be saying this while statement should be ended. So it will be simply break cover loop like this. So after doing our operations, we can simply perform our printing procedure like this. I topmost location I plus plus enter G and So I'm not going to explain these things one by one because I've been explained so many times about these printing statements. So I just simply write it. Before printing, we can also print a message like uh, the stack or something, whatever you prefer. Okay, I think our code is done. Let's compile. Okay, it is not having any errors. Let's run. Okay, so do you want to perform the pop operation? Yes. The value 5 deleted. Do you want to? Okay, it is not clear, right? So it's better maybe we put a new line method over here. So it will be much clear. Compile, run. Enter yes. Why was that? Okay, so the issue won't take place over here, but this takes place over here. So I'll put that new line method like this instead of putting it over here. Compile and run again. Okay, the value 5 is deleted, and I perform my pop operation again. The value 7 is deleted. So if you look at our stack over here, now you see first it deleted our topmost location, then it will be decreased by 1. Therefore, when I'm performing again my pop operation, it will be deleting 7. So like this will be sequentially happen. So like this, let's say I'm deleting my all values. Okay, so now my stack should be considered as it is empty. And when I perform my pop operation again, it will be saying stack underflow because it is not having any kind of element at my stack. So when it, but generally it is not deleting any element of the stack. It is just decrementing our topmost location because top is some kind of a, let's say, some kind of an indicator. Okay, it's not a pointer, but it's an indicator to point out some kind of a location. Basically, it's not actually deleting values that consist as the stack because the stack is static data structure. Therefore, you can't basically perform deletion operation over here. It's just simply saying your value is deleted by on considering our topmost location. So yeah, you might be confused what I'm saying right now, but you will be uh, able to understand what I'm saying is when it comes to linked list procedure, because when it comes to dynamic data structures, these things will be clear you to guys. So for now, just remember this pop operation, it is not actually deleting values that consist on your stack. It is just pointing out or indicate uh, whether your value is deleted or not deleted by only considering topmost location or the top variable. Okay, let's perform our division operation again. It should be saying stack underflow. Okay, stack underflow, and it will be saying some kind of weird things. The value 17 is deleted or some kind of a weird thing because it is not existing. Okay, so if I was -1, our uh, program will be ended, but it is not printing our stack. Why was that? Okay, because I have been deleted all of my elements, therefore it can't print any kind of values. That's why it's not printing any kind of value. So if I deleted only, let's say, 2 elements, and if I enter -1, there will be printing 2, 8, 56. Okay, yeah, so it should be printing up until the topmost location. So it should be there should be having equal sign also. Let's compile and run it again. minus 1, 1 minus 1. Okay, so now it's saying 2, 5, 56 and 9, and 7 and 5 has been deleted. Okay, so this is how pop operation works on this stack, and in the next episode we will discuss a new operation also. So thank you for watching this video.